Welcome back, fellow nerds. In today's video we will look at motion, and we will go through some terminologies that we're likely to find so we can make our life a bit easier, right? Okay, so we are going to look at speed, velocity, time, acceleration, distance, displacement. Okay. All right, so these are the few terminologies that we are likely to see under motion, but we'll just look at speed in this one because the question we're looking at is with speed related. So yeah, we are going to talk about speed, right? Okay, so speed. What is speed? So speed is some physicists say speed is distance, the change in distance with time, right? Okay, however, distance mathematically is written as final minus initial, which looks like displacement, and that is why some argue that speed should be written as path traveled, and others make it more specific by not just saying distance but saying distance traveled. So it is as specific as can be to say every path that you take, whatever path that you've taken, should be considered when you are talking about speed and over your total time. What does that mean? Okay, so if you are moving from point A to point B, right, you can either move a straight line, right? And a straight line, if you move in a straight line, you'll have initial and final, which will be easier for you to get the distance, right? Because distance in itself is considered to be the difference between the two successive points, which means you only have final minus initial, and that is in a straight line. However, if you are traveling from A to B, but then you choose to use maybe a longer route because you want to go watch football somewhere here, you want to go greet some friend here, and finally go to B, which could be likely church, but then anyway, or anything really. But then you choose to move this distance, or rather this path. So according to other physicists, they believe speed should consider this whole entire path traveled as compared to a straight line distance, because in as much as we both reach the same point, we've used different roads, and so you use a different path traveled, and so you consider that path traveled over the time that you've taken for that path traveled for you to calculate speed, right? So if you had traveled 100 kilometers using your long route and there was only 5 kilometers using your short route, your speed will have to consider the whole 100 kilometers because that is exactly what you traveled, unlike the 5 kilometers that is in between the two successive points. Okay, which comes back to displacement, right? Displacement is the difference in position, which means your final minus initial, which looks like this distance. So, and that is what you consider for displacement. However, speed you consider path traveled over the time taken for the whole entire path traveled. Okay, so let's look at the question to get a clear picture on what speed is. Velocity, we'll look at it when we look at a question that is related to velocity, then we can get a bit deeper into it. All right, we did look at it some time back when we were talking about scalar and vector. We said speed is a scalar, was given as an example of a scalar quantity that only has magnitude, as compared to velocity, which is a vector which has both magnitude and direction, because traveling from A to B requires you to travel a certain amount of speed with the right direction, because you cannot reach B if you are in the wrong direction, can you? Okay, so right, let's look at this question to cement on the idea of speed. Okay, so a person travels by car from one city to another with different constant speeds between pairs of cities. She drives for 30 minutes at 80 kilometers per hour. Okay, so let's look at this. She drives for 30 minutes, 80 kilometers per hour. What else? 30 minutes at 80 kilometers per hour. Then she also travels 12 minutes that is at 100 kilometers per hour, right? Then travels 45 minutes at 40 kilometers per hour, and 15 minutes buying lunch and stuff, basically not traveling at no speed. Okay, what do we notice different between these two? They have different units, right? Because speed is kilometers, the standard unit for speed is meters, because that's like position over time, right? Position is length. We looked at this dimension analysis and stuff, length, standard unit, meters. So sorry, basically speed has got meters per second as its standard unit, all right, and time has got seconds. But in this question, they're not entirely being more questionable on standard units, but you cannot work with different standard units either way. So you have minutes, you have hours, so you have to convert one to another, so you can have like tens, right? So which one is easier? It's easier to convert the minutes than to convert the whole kilometer per hour, right, to minutes. Let's convert minutes to hours and have it easier that way. So this goes back to conversion, right? So conversion, when you have 30 minutes there, you multiply it by 1 hour is equal to 60 minutes, right? So you can cancel out your minutes. That should give you what? Half, right? So 30 divided by 60 will give you 0.5 hours. Okay. Then you have 12 minutes. 12 minutes, we have, that will be 1 hour over 60 minutes again. That will be 12 minutes divided by 60. You'll have 0.2 hours. Okay. You have 45 minutes applied by, that is 60 minutes. All right. So 45 divided by 60, you have 0.75 hours. All right. Then you also have 15 minutes divided by, so you have 15 minutes multiplied by 1 hour over 60 minutes, what is equal to, you have 0.25 hours. Okay, so this is your time here. This is the time, and these are the speed quantities that we have. All right, so what is our question? Draw a speed time graph to represent the motion. So speed time graph, what does that mean? Speed time graph. This basically means you have your y and your x graph. So your speed will be in the y-axis, your time will be in the x-axis. That is basically what they mean when they say speed time graph. This is a motion diagram, right? So you draw your x-y plane. So you have x, you have y, you have speed. So you always label your coordinate xy plane, right? You have hours this side, right? Okay, you have kilometer per hour. Okay, so you don't have to forget to label. You have hours, you have time there. Okay, so we begin. All right, labeling very important when you are drawing your xy plane. Okay, so we continue. Well, how is the movement? A person travels by car from one city. Okay, so she travels for 30 minutes. We've already converted that at 80 kilometers per hour. So 30 minutes, 80 kilometers per hour. So you can, so we'll say you have let's say you have 20, right? 40, 60, 80, 100, 120, right? So 30 minutes, which is converted to 0.5. 0.5 was at 8 kilometers, right? So to 0.5. Okay. So then what happens next? She traveled, okay, then 12 minutes at 100 kilometers per hour. Okay, so this person was okay, so she's driving 80 kilometers, right? Then she changes to 100 kilometers per hour. So she changes to 100 kilometers per hour. The time indicated from changing from 80 to 100 is not indicated, so you just ignore that part. You go to your 100, your 100. Then from there, she travels 12 minutes at that constant speed, which is 100 kilometers per hour, which is 12 minutes. So you say 12 minutes was, what have we found? 12 minutes is 0.2. So you say 0.2 plus 0.5. You add 12 minutes to your 0.5, right? That would be 0.7. So that would be 0.7. Okay, what happens next? And 45 minutes at 40 kilometers per hour. Okay, so she starts to reduce her speed to 40 kilometers per hour. So she applies a few brakes. She reaches 40 and she keeps it there. Then she moves for 45 minutes. All right, what is 45 minutes? 0.75. So we add 0.7 plus 0.75, which is going to give us 1.45. all right, what happens next? Okay, this is constant. All right, so what happens then? She says, and spends 15 minutes eating lunch and buying gas. Okay, so she is settled because she is eating lunch and she takes that time to rest and eat lunch and buy some gas. So that is 15 minutes. So 15 minutes. If she's buying gas and eating lunch, she definitely is not traveling. So she's applied brakes to 0. Okay, and then she takes 15 minutes. So this will be your 15 minutes. Okay, I can do this. Or that. Okay, so these are your constants, right? These are your constant speeds. Okay, all right, 15 minutes. All right, what is 15 minutes? 0.25. So we say plus 0.25. 1.45 plus 0.25 should give you, it should be 1.7 hours, right? Okay, so that is your trip. This is your diagram and how it should look like. Probably, I hope it looks more neat in your books and stuff. Okay, because it should. I mean, yeah, cleanliness and all that stuff. All right, well, that is about question 1. All right, question S. Draw a speed time graph to represent the motion, and that is the motion we've represented. Okay, so determine the average speed for the trip. We've talked about speed, right? Okay, average speed has a similar formula to actually speed, right? Average speed, because average speed just means, the overall speed that you've traveled, because assumably if you're traveling a distance of 1 mile, you cannot, you probably can, but it's unlikely that you'd maintain a constant speed for the whole 1 mile trip, right? Because then you probably have potholes. Okay, so you probably have potholes. You probably apply some brakes because there's people moving around. So those fluctuations in your speed, as will be shown on your speedometer, are those instantaneous speeds we talk about, right? And so you cannot really explain to somebody or maybe give a full report on those changes in speed for a journey of 1 mile and probably more. So that is why average speed comes in, where you can just give an overall of the speed that you had moved at, right? Okay, so that is why it's a formula is literally similar to the speed, which is average speed will be your path length or path traveled over time. Okay, so we don't really have a distance, do we? Path travel, we don't really know the path traveled to some degree, right? So we can use the diagram to find ourselves path traveled, given we have speeds. So we can use our typical speed formula, path traveled, to be okay, so your path traveled over time taken, right? Over time taken. Okay, so what is our speed? The initial speed that we had, 80 kilometers per hour. Okay, so we'll say this will be your distance 1 over the time 0.5 hours. Okay, so we're going to say 80 multiplied by 0.5, that is 40. Okay, so we have 40 kilometers. This is distance 1. All right, so distance 2 will be because now speed time, right? So distance 2 will be what is our speed for distance 2? 100, and our time was 12 minutes, which is converted to 0.2 hours. Okay, 0.2 hours. So that will be 100 multiplied by 0.2, that will give us 20 kilometers. Okay, that will be 2. So you have 3 had 40 kilometers multiplied by 45 minutes, which was converted to 0.75 hours. 0.75 hours, that is going to be for 40 multiplied by 0.75 hours, that is going to be 30 kilometers. All right, distance 3, well, there's no change in distance for the 15 minutes because it was the car was not moving, it was at rest. And so the total distance now is we have x1 plus x2 plus x3, right, which is 40 plus 20 plus 30 brackets kilometers, because it's the same units, right? So 30 plus 20 plus 40 gives us 90 kilometers. This is your total distance, your path traveled, right? Her path traveled. Okay, total time will be we already calculated 0.5 hours plus 0.2 hours plus 0.75 hours, right, plus the time that she took resting, buying lunch, because that is also time, right? That is also time taken. And like we said, for speed you have to be sure you take the whole time and the whole time only. Okay, so right, so you add all that, 0.5 plus 0.2 plus 0.75 plus 0.25, that will give you 1.7. and if you look at the motion diagram, you discover that 1.7 was our final time travel. Okay, so that's about it. So average speed will then be, what is our total distance? Our path traveled 90 kilometers over 1.7 hours. So average speed is going to be 90 divided by that. That will give us 52.94. Let's say 52.9 kilometers per hour. 52.9 kilometers per hour will be our average speed, which you can convert. Usually should convert to meters per second, because meters per second is your standard unit. Usually you'd need to convert to standard unit, so you can convert that to standard unit, right? Where you have 52.9 kilometers, which is over just 1 hour, right? You multiply that by what? This is 1 hour 60 minutes, right? Then you can also say 1 minute is equal to 60 seconds. All right, multiplied by, you have 1000 meters over 1 kilometer, right? So you cancel that, 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 you cancel that. You have 52.9 multiplied by 1000. The only units on top is meters. Then here you have what? You have 60 by 60 seconds, right? So you have 52.9 by 1000 divided by 60 by 60, which should give you what? 14.69, let's just say 14.7 meters per second. This is going to be your average speed in its right standard units, right? Usually if they are not specific on what type of units you should use, it is advisable to stick to standard units. Okay, let's look at the second example, or the third question. Okay, all right, so determine the distance between the initial and final cities along the route. initial and final cities along the route. Determine the distance between the initial and final cities along the route. What's the distance between the initial and final cities? Okay, the distance between here to here, so city A, right? Because in these cities, like the question was saying, a person travels by car from one city to another with different constant speed. So in where we have different constant speed, that is where we'll have cities, right? So this is basically a city, this is basically a city, because these are constants, right? This is basically a city, right? So the question is what? The question is determine the distance between the initial and final cities along the route. Okay, the distance between the cities, the initial and the final. You have that, you have that, you have that. Here you have no distance because the car was not moving, right? And we've calculated the distances already. So in individual cities, we calculated distance 1 to be 40 kilometers, which you can convert now because you are trying to stick to units. So we have okay, this is 1000 meters, 1 kilometer multiplied by 40 kilometer. So cancel your kilometer, cancel your kilometer. So we have 40,000 minus 1000, which would give you 40,000 meters. Okay, x2 will be what? X2 we calculated already as 20, right? So that will be 20 multiplied by 1000, which would give you what? 20,000 meters. X3 was 30, which is 30 by 1000 meters, which should give you what? 30,000 meters, right? So these are your distances between those individual cities, right? Then the total distance was, all right. So these are the distances between individual cities, all right? So if we are going to find the total distance, the distance between initial and final, we will just add all of them. And we already know it's 90 kilometers, which again, standard unit, 90,000 meters. Well, that's about it. I hope we have learned something, and I hope we meet in the next video for more examples. Thank you so much.